Good morning, y'all. Wanted to make a couple of videos here for you this week. So this first one is to help you see how to solve for magnetic field created by wire. A couple of quick things. So one is over the next 2 weeks you'll want to do your projects. If you're running into trouble, let me know sooner than later to get your actual, hi Hannah, to get your actual measurements done. Again, in about 2 weeks, we'll do another thing with those. So make sure you're working on those projects, getting the measurements done. The other thing I wanted to point out is I'm going to try with these videos this week a couple different locations. Let me know which one seems to be easiest. You want to help? Come on, you can come here and sit. Well, you can't sit in front of this board. So let me know what's helpful and what's not helpful and those sort of things as I kind of work on making these. Okay, so the first one is to point out kind of how do we go about solving for the magnetic field. So we talked about that magnetic fields are created by moving charges. So since a current in a wire is a moving charge, it creates a magnetic field. And the equation for that is B, which is the symbol for magnetic field, equals mu naught, which is called the permeability of free space. And the simplest way to explain that is it's how well magnetic fields go through empty space. And because there's a set rate they can travel at. And it's partly due off of the speed of waves, which is the speed of light, but it has to do with other factors as well. And then down here at the bottom you have the 2 pi r, which is because we know that from the first right-hand rule, we put our thumb in the direction of the current, and then our fingers wrap in the direction of the field. So it's a circular field around it. And then it's the current is the speed of the charge. So when we're trying to solve this, I set up this problem here. I don't know how well you'll be able to read it, but I'll read it off to you. What is the magnetic field created by a wire with a current of 1.7 amps, 2 centimeters away, and we will need to convert that, but we'll get there in a second. So I'm going to go ahead and draw this, what it looks like. So here is my wire. It's going into the board. I forgot to write that. But it's going into the board. On the problems I gave you this week, I did mention that. The way to show that it's going into the board, because it's hard to do 3D, is to just put a little X on it. And that X shows it's going in. If it was going out of the board, I would put a dot. It's kind of like the arrow hitting you in the face and the arrow going away from you, like the back tassels on the arrow. And then, so since this is going into the board, okay, so my magnetic field, my current is going in, and then my fingers wrap in the direction, so this will travel with a field around like this. And we want to look a distance of 2 centimeters away. So when we go ahead and solve this, we say B equals, I'll try to do this kind of large, the permeability of free space. Now the value of that is 4 pi times 10 to the negative 7th. I'm not worried about units here, for that at least. So this just becomes 4 pi times 10 to the negative 7th. Divide that by 2 pi. So you'll see right away that the 4 pi will always cancel down to 2. So the value you end up solving with is 2 times 10 to the negative 7th every time. But that's how the equation is set up. You running away? No, you staying here? Okay. And then we multiply it by the current, which in this case I told you was 1.7 amps, divided by the radius, how far out from the center of the wire we are, and that is a value of 2 centimeters, which is 0.02 meters. It's got to be in meters. And then we solve all the math out. So you want to use the scientific calculator here. I'll try to avoid that if possible, because I know not all of you have scientific calculators. You should be able to find an online free version of one, but they're not always the easiest to use. So when I solve all that out, I get a value here in this case of 1.7 times 10 to the negative 5th. Now the unit for this is Teslas, and that's the unit for magnetic fields. That's not how you write a 5? No, what's wrong with my 5?
You didn't Top down, yeah.
Is that better?
Yes.
Okay, alright, good. Everyone's a critic. And that's how you solve these. So they're pretty straightforward. Hopefully that will help you on solving out these problems. Try the concept questions. If you're not able to get the answer, let me know. Thanks. Have a great day.